we will see some numericals problems regarding optics. Okay. So let's start. So this is about me, and we'll start some numerical questions about optics. So the first question is: an object is placed at a distance of 20 centimeter from a concave mirror of focal length 15 centimeter. So let's simply draw the concave mirror. So if we put the sign convention of mirror, then we'll see the U is negative, which is 20 centimeter, and focal length is negative of 15 centimeter. So just put the mirror formula: 1 by V plus 1 by U equals to 1 by F. So 1 by V equals to 1 by F minus 1 by U. 1 by F equals to 1 by minus 15 minus 1 by minus 20, which will be and the LCM will be 300. So minus 20 plus 15, right? So minus 5 by 300, which is equals to minus 1 by 60, right? And V will be, this is 1 by V, right? So V will be minus 60 centimeter. So you can say at what distance from the mirror a screen should be placed to get a sharp image. Okay, so we can write at 60 centimeter we can put a screen to get a sharp image, right? And the B is, what is the nature of the object? For finding out the nature of the object, we can put the image of magnification, which is M is equals to H dash by H, which is equals to minus V by U, where H dash is the length of image and H is the length of object, right? Just simply put M is equals to H dash by H equals to minus of minus V, means 60 by minus of 20. So this is minus 3. Fine. So now see, the M is minus 3. So this is minus, means the image is inverted. Fine. The mod value of M is 3. So we can say the image is 3 times larger than the object. Now move to the second question. Thin rod of length F by 3. Thin rod of length F by 3. So along the optical axis of concave mirror of focal length F. So let's draw first. So this is the concave mirror, and this is the rod. This is the rod. The length of the rod is F by 3. Fine. Fine. And see, image of the focal length F emphasizes the image is real and elongated, just touches the rod. Okay. So this will be the image, right? This will be the image, and it is touching the rod, right? It is touching the rod. Fine. Now see. Touching the rod. Calculate the longitudinal magnification. Okay. Longitudinal magnification. Now see. So this is focus F. Fine. And if the object, sorry, if the image is touching with the object, so we can see that this is C, right? This is center of curvature, right? And the object distance is this. This is what the object distance is this, which is denoted as U, right? And the image distance is this is denoted as u dash. Just put it u dash. And another thing, as this is center of curvature, this is 2f also. 2f also. Fine. Let's put the this is L dash, means the length of the image is L dash. Right? So now let me write all this. So the longitudinal magnification formula is, so longitudinal magnifications m is equals to length of the image by length of the object. So we can write m is equals to L dash by f, right? Let the L dash be the length of the image. If L dash be the length of the image, then we can write m is equals to L dash by L, which is equals to L dash by f by 3, as in question the length of image is f by 3. So this is, from this, L dash is equals to mf by 3. Fine. If the image coincides with the object, so we can write that this point is C. So in this point, the image distance, which is denoted as, so let me write, let image distance is u dash, which is equals to r, which is equals to 2f, because we know that the r is equals to 2f. Fine. So u dash is equals to how much? See, u dash is equals to, u dash is the sum of u plus f by 3. Fine. So let's write u dash is equals to u plus f by 3. Fine. So u is equals to u dash minus f by 3. Fine. So this will be, now see, u dash is how much? U dash is equals to 2f. No, u dash is equals to 2f, right? So we can write 2f minus f by 3. So just LCM it, 3, 6f minus f, which is 5f. Right? So 5f by 3 is, which is equals to u. See, u dash plus L dash is equals to v. So let this is v, which is equals to the length of the image and the distance of the image, right? So v is equals to u dash plus L dash, right? So v is equals to u plus f by 3, which is u dash, plus L dash. L dash is mf by 3. Fine. So just LCM it, 5f by 3 plus f by 3, which is u, right? U is 5f by 3. So I just put this plus f by 3 plus mf by 3. Fine. Just LCM it, 3, just common the f, which will be 6 plus m, right? So we got the u, v and f, right? Now see, earlier I told that the image distance is u dash, but earlier I told that the image distance is u dash. I was saying this just not to overlap the concept, because actually the v means the image distance. Image distance means from pole to the image, the distance between pole to the image. So actually the image will be the image distance will be v is equals to u dash plus length of the object, which is L dash, right? So now we can just put the mirror formula. Okay. right? 1 by b plus 1 by u just 1 by f. Where is b? 1 by this one minus f into 6 plus m by 3 plus u is minus 1 by 5f by 3 and the f is equals to 1 by minus f, right? So this is 3 by minus 3 by f into 6 plus m minus 3 by 5f is equals to 1 by f, right? So this is 3 by f into 6 plus m, just common the minus term, plus 3 by 5f is equals to 1 by f, fine. So the 3 by f into 6 plus m is equals to 1 by f minus 1 by 3 by 5f, right? So 3 by f into 6 plus m is equals to 5f 5f minus 3f, which is 2f by 5f, right? 2 by 5f, sorry, f will not be there. Okay, now 3 by f into 6 plus m is equals to 5f by 5 minus 3. So f is cancel out. 3 by 6 plus m is equals to 2 by 5. So just multiply this in corner. So 12 plus 2m is equals to 15. Now 2m is equals to 3. M is equals to 3 by 2, which is equals to 1.5, right? So now the question is calculate the longitudinal magnification. So the longitudinal magnification is m. Longitudinal magnification is m is equals to 1.5. This is the answer. Fine. So now see, just put the formula. M is equals to length of the image and the length of the object. This is the longitudinal magnification formula. And as per the geometry, we have done, and just in this part, and there is only calculation. Okay. So this is a good question. Now let's move to the third question. Okay. See, one type of transparent glass is refractive index 1.5. What is the speed of light through the glass? It is easy, I think. It is easy for you also. Yeah. Okay. We know the mu is equals to c by v, and v is equals to c by mu, right? So v is equals to c by mu. So c is over 3 into 10 to the power 8 meter per second, right? So 3 into 10 to the power 8 by mu is 1.5. So 2 into 10 to the power 8 meter per second. Right? This is easy. Now let's move to the third one. Light travels from air to glass slab of thickness 50 centimeters. Okay. So the thickness of glass slab, which is denoted as d equals to 50 centimeter, right? And the refractive index of mu is equals to 1.5. What is the speed of the light in the glass? Easy, this is easy. So mu is equals to c by v, and v is equals to C by mu. So 3 into 10 to the power 8 by mu is how much? 1.5. This is the speed of light in glass, right? Okay. Now, what is the time taken by the light to travel through the glass slab? This is important. Time taken by the glass. So let the time, let the time is t. So we know time is equals to distance by velocity, right? So t is equals to d by v, which is d is equals to 0.5 and v is equals to 2 into 10 to the power 5, which is equals to 2.5 into 10 to the power 9, right? Now, what is the optical path of the glass slab? What is the optical path of the glass slab? Fine. So optical path d dash is equals to mu into d. Fine. So mu is 1.5 into 0.5 is d, right? D is 0.5. 50 centimeter. T is 50 centimeter. So 50 by 1000 meter, which is 0.5 meter. So I put the 0.5 in D, right? I just uh, calculated it in my mind. Okay. So 1.5 into 0.5. So 0.75 meter. Okay. So mu has no unit and D has the unit of meter. So the optical path unit is meter. Okay. And this is, so you can say 75 centimeter. So how can we conclude this? So you can conclude the light would have traveled. Okay. See, optical path is 20. Optical path is 75 centimeter, right? And the thickness is 50 centimeter, right? See, let me erase this. See, this is glass slab. Okay, this is glass slab, and the thickness is 50 centimeter, and the optical path is total optical path is 75 centimeter. So how much light have to cover more? So light have to cover more 75 minus 50, which is 25 centimeter. Okay, light would have traveled 25 centimeter more in vacuum. Okay, vacuum by the same time had there not been a glass slab. Okay, so this is the conceptual question. Now come to the next question, which is light traveling through transparent oil enters into glass of refractive index 1.5. Okay, if the refractive index of glass with respect to oil is 1.25, so glass with respect to oil, so mu GO is 1.25. What is the refractive index of oil? Right. So we know mu GO is equals to mu G by mu O, right? So mu O is equals to how much? Mu G by mu GO. So mu G is 1.5, it is 1.25, this is 1.2, right? The refractive index of oil is 1.2. Okay, this is the answer. Fine, easy question. Now move to the next question. See, a coin at the bottom of a throw containing three immiscible liquids of refractive index on 1.3, 1.4 and 1.5 poured one above to the other of the height of the 30 centimeter, 16 centimeter and 20 centimeter respectively. What is the apparent depth of apparent depth at which the coin appears to be when seen from air medium outside, in which medium the coin will be seen? See, when seen from the top, uh, look, this is the coin and the layers are there. When seen from the top, the coin will still appear to be at the bottom, at which the medium appears to be shrunk with respect to the air medium outside. Okay, so the first refractive index is 1.3, 1.4, 1.5. Okay, and the height is 30, 60 and 20. Okay, so d1 dash is equals to d1 by n1 as per the formula, and d2 dash will be same, d2 by n2 for the second, and for the third is this, right? Here n1, n2, n3 is the refractive indexes. Fine, fine. And the d dash will be the total depth. D dash will be d1 dash plus d2 dash plus d3 dash, right? Which is d1 by n1 plus d2 by n2 plus d3 by n3. Fine, and d dash is equals to 30 by, first is 30 by 1.3 plus 1, sorry, 16 by 1.4 plus 20 by 1.5 will be 47.8 centimeter. Fine, as the centimeter is there. Fine. Fine. Now move to the next question. The question is, what is the radius of illumination when seen above from inside a swimming pool from a depth of 10 meter on a sunny day? What is the total angle of view given the refractive index is 4 by 3? Right? So given refractive index is 4 by 3 and the depth is 10 meter, right? Depth is 10 meter. This is the depth is 10 meter. Refractive index is mu. Right? So the radius, find the radius. The formula of radius is, this is the cone. The radius of cone is r. Then r is what? As per the formula, d by root under mu square minus 1. Right? Just put the formula. D is 30. Sorry, D is 10 and mu is 4 by 3 square minus 1. Okay. So 10 into 3 by 16 minus 9 is root. So r is equals to 30 by root 7, which is approximately equals to 11.32 centimeter. Fine. Now the question is, what is the total angle of view? Now we have to find the angle also, right? So we have to find the angle also. Now just remove this. See, this is the cone. This is r, and this was the mu, right? The formula was IC equals to sine inverse 1 by mu, right? The VU angle of cone. The formula of VU angle of cone is IC is equals to sine inverse 1 by mu. Fine. IC is equals to sine inverse mu is 1 by 4 by 3, which is sine inverse 3 by 4. IC is equals to sine inverse 3 by 4. So this is IC, and the total angle is IC into 2, which is 2 into sine inverse 3 by 4. The approximate value of sine inverse 3 by 4 is 48.6 degree. So which is 2 into 48.6 degree, which is equals to 97.2 degree. So this is the answer. So now the question is, a biconvex lens has radius of curvature 20 centimeter and 15 centimeter each. So just draw it. This is one curvature, and this is the second curvature. This is one curvature, this is second curvature. The first curvature is the radius of 20 centimeter, and the second curvature is the radius of 15 centimeter, right? 15 centimeter. The refractive index of the material of lens, the total refractive index is 1.5. What is the focal length? We have to find the focal length. Will the focal length change if the lens is flipped by the side? Okay, so this is nothing, just remove it. Okay, for a biconvex lens, the radius of curvature of the first surface is positive and that of the second surface is negative, right? See, this is a biconvex lens. The radius of curvature of this side is 20 centimeter and this side is 15 centimeter. So if we put the rule, then we'll find that this is positive side and this is negative side. So we can say that one side is positive and the another side is negative. Numerical formula is formula is 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. Fine. This is the formula. Fine. So let me just remove this and this. Fine. This is the formula, and the given terms is given. Mu is equals to how much? 1.5, and r1 is equals to 20 centimeter and r2 is equals to, let's say this is the minus term and minus 15 centimeter. Okay, and just put the values in the formulas. 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2, right? So 1 by f is equals to mu is how much? 1.5 minus 1. 1.5 minus 1 into 1 by r1, which is 1 by 20 minus 1 by minus 15. Fine. 1.5 minus that is 0.5 into, just LCM it, plus 1 by 15, which is 0.5 into which is 60, 3 plus 4, which is, this is 1.5 means how much? Half, right? This is half. Right? So 60 into 2, 120 by 7. So f is 120 by 7, right? This is 1 by f, so f is 120 by 7. Right? So this is, if we 120 by 7 is equals to how much? 17.14 centimeters, right? As the focal length is positive and the lens is converging lens, right? This is the converging lens. Because the focal length is positive, f is positive, so the lens is converging lens, which is called convex lens, right? Convex lens. Now will the focal length change if the lens is flipped? See, will the focal length change if the lens is flipped by the side? So if this is the lens, if the lens is flipped by the side, will the focal length will change? Now see, if the lens is flipped back, then the case is this. Then R1 will be 15 and R2 will be 20, right? The 1 by f is equals to how much? 1.5 minus 1, because mu is constant of this lens, for this lens. So 1 by 15 minus 1 by minus 20 will be there, right? So just 0.5, 1 by 15 minus plus 1 by 20, right? So this is half into 60, 4 plus 3. So this will be 7 by 120 by f is equals to 120 by 7, which is equals to how much? 120 by 7 is equals to this 17.14, right? 17.14 centimeter. The conclusion is the focal length will not changed by flip. Right? This is the question, which is easier because just the radius of curvature is there and the mu is there. Just put the formula and flip. Just radius of curvature is, then will be flipped again, and the formula will be same as this, right? Let's move to the next, which is if the focal length is 150 centimeter of the glass lens, what is the power of lens? This is the most easiest question. It is f is equals to 150 centimeter. The power of lens is, you know, the 1 by f if f is in meter, and if f is in centimeter, then p is equals to 100 by f, right? So just p is, this is centimeter, then 100 by f, which is 100 by 15, which is 0.67 diopter. Okay, diopter. So as p is positive, the lens is converging lens, right? This is the easiest question. So the last question is this: what is the focal length of the combination of the lens of focal length minus 60 centimeter is brought in contact with the lens of the focal length 150 centimeter, which is the power of the combination, right? So the focal length of the lens, first lens is f1 is equals to minus 70 centimeter, and the f2 is 150 centimeter, right? The formula of lens in contact is 1 by f is equals to 1 by f1 plus 1 by f2, right? Just put the value, 1 by f is equals to 1 by minus 70 plus 1 by 150. So 70 into 150 is equals to 10500, and minus 70, 150 minus 70, 80 will be there. F is equals to 10500 by 80, which is 1 cancel, 1050 by 8, which is I think there will be a minus, right? There will be a minus. So this is minus 1 3 1.25 centimeter, right? This is the answer. just put the formula 1 by f is equals to 1 by f1 plus 1 by f2. So we have discussed some numericals, important numericals about this chapter, which is optics. So thank you. Jai Hind.